Welcome to this explainer. So, you know those optical illusions, the ones printed on a flat, totally stationary piece of paper where you could have sworn the shapes were physically vibrating or spinning? You know rationally that the page is completely still, right? But your brain is just absolutely insisting that it's moving? Well, today, we're going to explore exactly why that happens by diving into one of the most fascinating paradoxes in math, physics, and art. We're looking at how absolute stillness, we're talking rigid, unchanging, fixed geometry, can inherently encode dynamic, perpetual motion. Now, I know that sounds completely counterintuitive. Impossible even, right? How can something that literally never moves create this undeniable, almost physical sensation of infinite kinetic energy? I want you to really keep this question in the back of your mind as we go through today's material. How can a completely still image, a frozen mathematical equation, or just a static symbol contain infinite kinetic energy? You see, we rely almost entirely on our eyes to tell us the truth about our environment, to tell us what's safely stationary and what's actively moving around us. But we're going to challenge your visual processing today. We're going to see just how easily those senses can be completely betrayed by geometry. And by the end of this, you might just question the fundamental nature of how your brain perceives reality, space, and motion. Okay, let's dive into this by defining the core framework that bridges this whole paradox. The concept is called non-duality. And when we talk about non-duality in this specific context, we aren't just talking about some abstract philosophy. We are talking about a structural, conceptual state that exists precisely on the razor's edge. On one side, you have rigid, static order, and on the other, chaotic, unpredictable motion. Think of it kind of like a surfer riding a massive wave. They are perfectly balanced, holding this rigid, static pose, but they're doing it right in the middle of roaring, chaotic, forward momentum. That razor's edge, where order and chaos meet, that is where all the magic happens. And it's the ultimate bridge we'll be exploring today. To ground this idea, let's start with something you've definitely seen out in the wild, the golden mean, or the golden ratio, represented by the number 1.618. You can find this ratio everywhere, from the sweeping spiral of a nautilus shell to the architecture of the ancient Parthenon. Just picture a golden rectangle for a second. It is not perfectly symmetrical. That ratio, roughly 0.6 to 1, is just slightly more than half. Now, the human brain absolutely loves symmetry. It's how our pattern recognition functions are designed to finally rest. But because of this specific asymmetric equilibrium, it creates this visual sensation of expansion and diminishment. It's close enough to a symmetric balance to please our mind, but just asymmetrical enough to pull the eye, implying a subtle, continuous visual motion. We see a very similar resolution of opposites in the Taijitu, which you probably just know as the yin-yang symbol. This symbol represents perfectly balanced binary opposites. We're talking day versus night, clean versus dirty, man versus woman. But it's actually the geometry of the form itself that is so captivating. It isn't just some static, boring line drawn straight down the middle of a circle. It's a dual spiral. That sweeping, swirling division resolves those static binary states into a unified, dynamic whole. Because the curvature mimics a wheel in motion, it actually forces the human eye to perceive a continuous rotation. Your brain literally sees a spinning disk where, physically, there is absolutely zero movement. And within that swirling implied motion, there's a really profound psychological truth. As the source material beautifully notes using Jungian terms, proportionally, we all have a bit of shadow. Every single side of the yin-yang contains a tiny component of its opposite, that little dot of contrasting color. It infers that even duality itself is flawed or imperfect. This bitonality makes it an incredibly rich, non-dualistic metaphor for the human condition, basically saying we are all a static balance of chaotic, conflicting traits. Now, this psychological blur between two states has a direct, tangible equivalent in hard mathematics, which is where things get truly mind-bending. All right, prepare to have the rug pulled out from under you. This is the Mandelbrot set. It is a strictly static mathematical object on the complex plane. Essentially, it's generated by a mathematical feedback loop, just a simple iterative equation that you run over and over and over again. But the incredible duality it physically resolves is just staggering. The entire set is contained within a completely finite area. It physically never extends beyond a radius of 2. You could quite literally draw a circle around the whole thing. Yet its boundary is an infinitely complex perimeter. This is called infinite self-similarity. No matter how many millions of times you zoom into the edge of this shape, it just keeps generating new, endlessly intricate borders. And because an infinite perimeter is somehow trapped inside a finite area, our visual processing centers interpret this as perpetual continuous motion inward. You literally cannot stop your eye from falling into it. Which brings us to aperiodic geometry, specifically Penrose tilings. Imagine trying to build an entire universe using just two primary, completely static shapes, known as kites and darts. But here's the catch. Normally, when we tile shapes, they have what's called translational symmetry. Think of a standard checkerboard. If you slide the pattern over a few inches, it perfectly matches up again, right? But the mathematics of these kites and darts completely strips them of translational symmetry. When you connect them, they are mathematically forced to create a two-dimensional plane that is purely aperiodic, meaning it never repeats in a predictable periodic loop. No matter how far you slide it, it never matches up. Ever. So what does that lack of symmetry actually do to your brain? Well, when you look at a Penrose tiling, you actually feel this weird hum of kinetic energy. Why? Because human beings are evolutionarily hardwired to spot repeating patterns. I mean, it's how our ancestors survived, looking for the repeating pattern of a predator hiding in the tall grass. So when you look at these tiles, your visual cortex is desperately trying to resolve a resting symmetry that simply never materializes. That motion you feel isn't in the geometry at all. It's just a cognitive, unresolved state oscillating continuously in your brain. It's a non-dualistic state existing precisely between absolute randomness and rigid crystalline order, acting kind of like a cognitive itch you just can't scratch. We can actually translate this exact concept into computer science using Wolfram's Rule 110 cellular autonomy. Now, what's really interesting about this slide is how it relies on an incredibly basic 8-state Boolean logic rule. It operates on a super simple premise. It just looks at a cell and its two immediate neighbors and assigns a 1 or a 0 for the next step. That's literally it. It is a completely unyielding, finite, and deterministic static parameter. It's about as rigid and boring as basic math can possibly get. But when you map this one-dimensional evolution onto a 2D grid, using the vertical axis as time, something miraculous happens. That static, rigid code generates localized propagating structures called gliders or spaceships that interact across a background texture. Your visual cortex suddenly sees these independent entities gliding and moving through space, but it's purely an illusion derived from tiny, local, completely static calculations. Even wilder, Rule 110 is a Class 4 automaton, meaning it operates right on the exact boundary of order and chaos. And it is Turing complete. To put that simply, this tiny static set of 8 rules possesses the mathematical capacity to simulate literally any computer program in existence. It could theoretically run Windows, play a video game, or calculate the digits of pi. It is the ultimate proof that an incredibly complex, dynamic universe can be birthed from completely static code. Let's move over to Aristide Lindenmeyer's L systems and see how this whole thing builds into the physical, living world. Lindenmeyer created a formal grammar, a starting text string called an axiom, and some static production rules. It works like this. A becomes AB. B becomes A. Iteration after iteration, step by step, this static string of text aggressively rewrites itself into longer and longer sequences. And this brilliantly illustrates the magic of non-duality in biology. When you interpret those static string rewriting rules as basic geometric drawing commands like draw a line forward or turn left by 20 degrees, they generate breathtakingly complex branching fractal structures. They perfectly simulate the messy, real-world biological morphology of trees, algae, and vascular systems. Just imagine the branching veins in a fallen leaf, the sprawling delta of a river, or even the microscopic bronchi in your own lungs. The entire timeline of an organism's organic, seemingly chaotic growth is entirely compressed into a rigid, highly deterministic block of static code. All right, let's escalate things from computer simulations to physical, acoustic reality. Have you ever seen Chladni figures? This is the direct physical materialization of kinetic energy into geometry. Step 1, you distribute completely random particulate matter, like fine sand, across a rigid metal plate. Step 2, you vibrate that plate at very specific resonant frequencies. The plate begins this violent, chaotic buzzing. Then, step 3, suddenly, in the blink of an eye, the sand snaps into highly symmetrical, static geometric patterns called nodal lines. These are the precise areas of the plate that remain perfectly, quietly stationary, while the rest of the metal around them violently oscillates. So the crucial point is the illusion versus reality motif. If you want to understand the delicate relationship between structure and energy here, you have to look past the surface. These stunning, rigid, crystalline geometric shapes you see on the plate, they only exist because they are being actively sustained by continuous, invisible kinetic motion. The static shape is quite literally trapped kinetic energy. It's a pure illusion of stability.
Because if you cut the power and that underlying kinetic vibration stops, the structural integrity of the geometry instantly collapses. The beautiful mandala just instantly turns back into a lifeless, chaotic pile of sand. Finally, we reach the absolute climax of deterministic chaos theory: strange attractors, specifically the Lorentz attractor. The underlying math here is just three static, nonlinear, ordinary differential equations. But when they are plotted out in three-dimensional phase space, which is really just a mathematical map showing all possible states of a system, they create this famous static butterfly geometry. But this butterfly is a total paradox. The geometry you're seeing actually represents an infinitely long, continuously moving trajectory of a particle. The infinite thread drawing the butterfly never ever crosses itself, and it never loops exactly the same way twice, yet it is completely trapped inside this finite static box.
The Lorentz attractor resolves the ultimate non-duality. Just think about the massive contrast here. On one side, you have absolute mathematical determinism, rigid, fixed, perfectly predictable static rules dictating every single movement. On the other side, you have chaotic unpredictability, the wild, infinite, non-repeating, dynamic variation of a particle flying endlessly through space. And yet, they are exactly the same thing, bound perfectly together in one beautiful, unmoving static shape. Which leaves us with this final, really profound question to consider today. From the expanding asymmetry of the golden ratio all the way down to the infinite thread of the Lorentz attractor, we've seen how absolute stillness directly encodes infinite motion. So, if static geometry perfectly maps the messy, unpredictable chaos of our entire universe, is the kinetic energy, the movement, and the flow of time we feel every single day simply an illusion of the underlying code? I'll let you ponder that. Thank you so much for joining me on this explainer, and remember to keep questioning what you see.